Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Good day, everyone, and warm welcome to ISA Oman section Knowledge Connect webinar series. We are delighted to have you all with us today as we continue our journey of learning, sharing, and professional growth. As part of our ongoing commitment to advancing knowledge within the automation and industrial technology community, we are excited to share with you that we have a number of engaging and insightful sessions lined up this week and upcoming week, inshallah. These will cover a wide spectrum of topics, including cloud computing, instrumentation and calibration, electrical system and power generation, generative AI governance, cybersecurity best practices, building your own cybersecurity home labs, and many more. Our goal is to enable continuous learning and foster collaboration among professionals in various engineering and technology domains. Today, as we kick off the second season of ISA Oman Knowledge Connect, it's our pleasure to host one of our distinguished Omani professional in the power and SCADA field, Engineer Mohammed Koora. Mohammed Koora. Engineer
Yes, Nasser. Hi, Nasser. Welcome, Nasser.
Engineer Mohammed Koora is well recognized in his expertise, dedication, and contribution in the industry. And we are very pleased to have him with us to share his knowledge and insight. Welcome on board, Mohammed. We are honored to have you here. Let me give a short introduction about Mohammed. So Mohammed is an experienced OT cybersecurity engineer and SCADA engineer at Petroleum Development Oman PDO, with a strong technical foundation in industrial system and critical infrastructure. Mohammed earned his bachelor in electrical and electronics engineering with major in telecommunication and signal processing from Sultan Qaboos University, SQU. Prior to his current role, Mohammed served as power SCADA system engineer at PDO, where he was responsible for supervising and controlling over 30 field stations and more for more than 5 years. Mohammed, the floor is yours.
Welcome, Nasser. I'm so glad to be here, and I'm so excited to start the second season with Knowledge Connect with my session, which is regarding cybersecurity and SCADA for power system infrastructure. So, inshallah, I hope the whole audience will enjoy. I'm trying to make it as simple as for everybody to understand it, and we will take them as step by step, inshallah, to reach up to our level.
Inshallah. Before starting, just reminding our viewers, please make sure that you put your comments, questions in the comment section wherever you are watching from our social media platform through X, LinkedIn, YouTube. Once you put it, we will collect this question and we will share it, or we'll ask the engineer Mohammed Koora at the end of the presentation, inshallah. So,
inshallah.
Without further ado, Mohammed, the floor is yours.
Thank you, Nasser, and welcome all for our session today, which is about SCADA and OT cybersecurity for power infrastructure. First of all, before I'm starting our session, let's a little bit about myself. I'm Mohammed Koora. I am a member in ISA Oman section. I have 13 years experience in this field, starting with electrical supervisor, then I shifted to SCADA engineer. I end up with OT cybersecurity. So just in our topic, which we are talking about SCADA and OT cybersecurity for power infrastructure. Before we are talking about OT cybersecurity and talking about SCADA, we should have at least the basic of the system which we are control and protect. So the first point, we will talk about the power system infrastructure. What is the power system infrastructure? It's contained of three main sections. We will know about them. Then we will shift to another topic, which is why we need to control. Why we don't leave this power system run without any control, without any monitoring and protection, and which parameters we should look for it when we are going to control this power grid and power infrastructure. Then we will talk about the third topic. We will talk about the tools we will use it, which is the SCADA tools, and we will see the architecture of that SCADA tools, how it is look like, what is the big component. After that, we will talk a little bit deep in advanced topics, which is about the communication. So we'll start with ISA 618050, which is about the communication inside the power station, substations. And then we will go to another communication, which is use another standard, which we call it ISA. We will call it shortly IC 104 protocol. Then we will end up with the final how we can secure both of these communication in our power system. First, when we are going to talk about overview for power system infrastructure, we need to know that our power system consists of three main sections, starting with generation, then transmission, and end up with transducer, with the distribution. So why we need this each one of these sections and what is the purpose? We will go in the brief, we will discuss about them, and we will give you a main component for each part of them. Let us start with the generation. In the generation, what is the generation? In the generation, we aim to convert a source energy from different natural energy to the electrical energy. So it depends on the type of the energy, the source energy. We have different type of power plant, which is in the generation section. So the type of power plant we have it is a gas turbine, steam turbine, and also wind farm, which is and solar. Let us go a little bit deep to talk about the things which is commonly used in our generation site, which is gas turbine. How our gas turbines works? The gas turbines have two inputs. First, we will start with the air. There is an air will be enter our gas turbine from the inlet, and it will be compressed. Then it will be shifted to mix it with the fuel in the combustion. In the combustion, there will be combustion, and they will produce an energy. That energy will be able to rotate some plates on the shift. So as you can see in the hour graph, there will be a shift. The shift connect between the hour turbine and the hour generation. As much that to start to rotate, that will rotate the hour shift. So in other side, in the generation, as we all know for electrical, whenever we rotate our router, it will produce a magnetic flux in its surface. That will be traveled to other side of the generation, which we call it stators. And from other side of the stators, we can find our electricity. So now we can end up with electricity in the simple way. So now we finish. We end up with electricity. But unfortunately, the utility, the residential, and what is it, industrial, nowhere will be nearby our generation plant. So we need to transfer this power to other distribution system by another section, which we call it transmission section. What's the aim of the transmission section? As we know, the transmission section will transmit our electrical power from the generation power plant up to distribution. And the main concept with us is we try as much to raise the rate of the voltage to reduce the losses of the power. So from that perspective, we always in the transmission, you will find our rate of the voltage is more than 132 kV, 22 kV, and up there. So what is the main component in our transmission system? Usually, if you look at it in general, you will find it like overhead lines, network with overhead lines between the substations. In their substation, there is a one main equipment, we call it transformer. Generally, transformer will be two types, either step up or step down. The step up is to convert the voltage from lower rate of the voltage to the upper rate of the voltage, and that will be always located near to the power plant. And the other type of the transformer will be step down transformer, which will be located in the distribution section or near the utility or residential or industrial area. There is another system there in our substation. We call it like protection. The protection helps us whenever there are any fault happening in any section of our power grid. It will isolate it from the others to keep the other system healthy. And the last thing we are talking about the SCADA. SCADA will help us to monitor and control our power grid. Let us go to the third section of our power transmission. The last one, which is we call it a distribution. What is the main of the distribution is to deliver our power to the utility, to the end users. What is the kind of them? Is it commercial, industrial, or residential? So we try to deliver to them the power with the manner, safety and reliable manner. There is several type of distribution. It depends the capacity of the feeders which we provide. If it is a single feeders, which is direct, we call it radial system. And if we want to connect a critical load or something with the two source, we try to put it in the loop, and we call it ring connection. And there is another complicated way, we call it network system. In that distribution, when we become near to the utility and the user, we will realize that the voltage will become low. It will be like 33 kV, 11 kV, and also for 15 voltage. So now I think we end up with a clear general overview about our power system, how it is produced, transmit, and then end up distributed to the end user. Now, from this section, I would like to understand why we don't keep our power system run by itself, why we need to monitor it, why we need to operate it, why we need to control it. And if we are going to control it, operate it, what is the main parameters which we are looking for? And also, what is the tools that help us to maintain, to control our power system? First of all, to answer the question, we need to provide a power from generation to the distribution with a good, reliable, and available and secure manner. That will help us to be available all the time, secure our system from any abnormal or fault or anything happening. So in case to make our system as power stable, so we need to look in certain parameters. First is the part. Let's now go a little bit deep technically. So the main parameters which we are looking for is it is voltage and frequency, and also the power factor. Let me start with the voltage. What will happen if our voltage is become more than the rated voltage in any bus? And what will happen if our voltage become less than that? So we will start with it. The power is under voltage. If our voltage is under voltage, yeah. Whenever the voltage reach to the end equipment in under voltage, the equipment will not run because the equipment is designed and manufactured to the certain rate. And that, so if we could not supply for it the rate which is designed for, so it will not run, so the system will end up with a lot of equipment which will be tripped. What will happen if the voltage become more than the rate in each bus or any place? So that will cause to harm our installation. That if there any installation harm, that will be maybe cause the what is called it uh, that will cause maybe to manufacture the equipment which is there, and it will be causing partially discharge for that equipment. So that is regarding the voltage, and we will shift to the one who is interesting. It is a frequency. Why we are going to control the frequency parameter? If you the frequency, it will be balanced between the generation and the load. For the people who does not know what is the load is the power we are consuming. So we are generate power, it should be equal to the power which we are consuming. So we have to balance between them. What's the parameter will help us to balance between these parameters is called frequency. What will happen if the load of the residents of the people consume more than the power which we are generating? That will cause a frequency to drop. In case the frequency drop, in reality there will be operators to operate and control and do a lot of work. But imagine there is no operator, no protection system at all. So that will cause, if our load is increased and the frequency drop, that will cause to blackout of our system. So in other hand, if our generation is more than our load, what will be happen? That will cause our generation to run in high speed. That high speed will be affected our GT or our turbines, and that will cause damage for that. And our GTs and turbines is really very costly, so it will cause damage and a lot of losses in the companies. So we'll end up with the third parameter, which is the power flow. We will talk about reactive and real power. So whenever we are produce a power, there is something called reactive power and real power. And then it's something also, so then we call it appearance power. That should show us the quality of the power. We usually try to maintain that is as much as power we produce should be like a real power. So we maintain something called power factor in our grid to give us as clear as much as possible. We will never reach to that, or we try to reach it to 1 unit, but we will never be reached to that. But we will keep it nearby that one. So that is in general what we are controlling, what we are trying to monitor, and at the end we try to protect our system. Whenever anything is happening wrong in our system, we try to isolate the affected place and keep the other place healthy. So from that point, we will talk about the tools, which tools we are used to control and monitor these equipment. Usually we will start with the basic tool, which we call it SCADA. SCADA is supervisory control and data acquisition. That is, in brief, we can say it will collect a data from real time. So what is the rate or what is the values of the voltage measurement in the hour bus and anywhere that will collect it. Even it is more than that, it will show us the status of our equipment like breaker and other things. Then there is another tool, which is advanced tool, we call it energy management system. That tool is used to help us for forecasting. It will give us a forecasting, it will give us analyzing about and it will give us more about optimum power we require. So this is the more advanced tools, we call it energy management system. We will end up with a third tools, which is called it AGC, which is automatic generation control. When I'm talking about the frequency to balance between the load and the generation, in reality, we don't have one generation and one load. It is really something complicated, a number of generation, a number of loads. So this system will help us how we can maintain this one. So with this system, even we have a certain of control, like a drop mode, control, pre-select, and these things, which is advanced selection mode, that help us how the generation or the unit will proceed whenever there is any change in our frequency. At the end, what I wanted from you as you attending this, I want you to take this the table as the brief for what I am saying. So the main parameters maybe we'll take it is as frequency and the voltage. What will happen if that voltage become low or higher, and what is the main risk. So now we will go more deep in our system. We will talk about SCADA, and also we will talk about architecture, how the SCADA look like. What I want from you to know about the SCADA, I want you to know the component of the SCADA, and what is the part of the SCADA, and what's the communication between these parts. So let us start. This is the general architecture about SCADA system. This is a tool we use it to control the field and to take real data to our main controls center. So the main part, when we look to the SCADA, we will look at it from like a general view. It will consist of three main parts. The first part will be located in the main control center, which is combined of SCADA servers, which is dealing by SCADA engineer, who is adding who is doing modeling and adding data there, and is mainly working with the system to install a new substation, everything. And also it will be their HMI. HMI is a screen that present all the things, all the data, and even SLDs for the operator. Also, there is a huge number of the servers for different functions, but I mentioned like here for HIS, which is usually used for historical. We can collect or you can retrieve a data for long term back for study, for case study and this. So this is the blue one, this is the first part. We'll shift to another part which is more important, which is the orange part, which is in each field. In each field, normally we will find these three things. We call it the field device. The main device we find it there, we call it RTU. The RTU is a remote terminal unit. It is working as to collect the data from the field and then convert it to the sequence that can be traveling through the media, the communication media, up to our main control center. And also we can find also there is a device called IED, which is intelligent electronic device. It is a numerical relay. It will be like a brain for protection team. Whenever anything happens, it will be react. They will have a set point. From that set point, you can at least it will be some action happen, like open breaker or different another things. At the field by itself, you will find there is two things to collect the data, and one thing is like actuators and the lag sensor. Let us talk about it in the next slide. But before we go to the next slide, we want to know, as we are talking deep in our advanced and technical topics, we are talking about the standards. So in the site power substations, we have a protocol called IEC 61850. That is a planned the standard for some number of protocols, which is used to communicate between these devices. These devices need to talk to each other to update what is happening there inside the substation. And also we have another protocol which we call it IEC. Shortly we will call it IEC 104. That is between center. The things, the signals, the data we need to transfer from the substation up to our main control. In brief, I will go through how is the communication inside the substation. First of all, we have the inputs. In our system, like power, we have limited parameters which we take it from the site, which is current and the voltage. The rest parameters, it will be calculated inside the relay or different things, which like frequency, power factor, real power, and other things. So mainly we will take current and voltage, but what is the kind of sensors which we have it is a CT and VT. That will convert the rate in our what's called our real line. It will be high, then it will convert to low, which can be deal with IED and MFM. So here MFM, what is MFM? Mainly MFM, we are using it for only monitor only multi-function meter. That is, we'll take a data and measurement and we'll transfer it to our system, which is through RTU, then the SCADA. So in brief, the signals which is coming from site, it will go through the CT as and on VT as sensors. Then it will it will process inside AED or automatic AED and EMF. And then from EMF, it will reach to RTU. The RTU main role is to convert it to the digital signal, which can travel through connect media. And then SCADA, we found in the SCADA in the other hand. But what about the output? The output is whenever the operator in the master control, he try to send any command or any things, it will send it through the RTU. Then from the RTU, it will also go through IED, and then it will be like open breaker or close the breaker. It will be like an actuator. So that will be in case what if we are going to talk more details, what is the type of communication we use? As you can see, Modbus RTU and the same one which we call it 16850. We have two protocols we call MMS, and we will go deeper regarding this Angelus protocol. Also, if we, as people who is in cybersecurity, they know about the Bordel model, we will realize we are talking about layers between layer 0, 1, and 2. So let us go more about IEC 61850, power substation. What is the benefit of this protocol? Let us take it simple. From this slide, from this chapter, I need you to understand that this protocol is very fast communication. We are talking about milliseconds, and it helps the equipment, IEDs, that numerical relay came from different vendors to understand each other. So they have the same language. They can communicate with each other. We call it interoperability. So it will not be any monopoly from one vendor or one OEM. Another thing, it is very simple to configure it. So what make this protocol have these features? There are three secrets, which I consider there as the three pillars for this protocol or standard. The first we will start with. Now we will start with this. But before we are going to talk about these details, we need to take a quick recall about our system, about our power system. First of all, in power system, for the people who do not normally know about power system, there is something called SLD. It's showing us, as I mentioned in the beginning, the generation, then is the line. From that, the other section is for transmission, there is transformer, and there is a substation which having busbar, then is the feeders and also the breaker. Imagine in each breaker we will have IED, which is a relays and everything to control the breaker whenever it need to be tripped or to be opened. So this is in general. So as a protection, they want each one of this equipment is very high, very important for us. So we try to protect it from any abnormal things. So in protection, we have something called protection system requirement, and that will help us to understand what is the benefit of this protocol. From that, I will not go for all of them, but I will take a sample for the things which I need later on. So I will talk about reliability. It will take a fault whenever it occurs. It will never occur with no fault. And we'll talk about speed, sensitive, and also we'll talk about coordination. Let us talk about the coordination here in other side for protection zone. Look, the zones for protection, we protect each equipment in its independent with a different zone. But if you realize there is some overlap between that, why we need that? Because there is something called coordinate. Whenever if there any relay cannot energize or send or send signal for the breaker to trip or something, there will be another backup relay, which is I'm talking about IED. So that will help that from your understanding now, there is a communication between these relay. And when we talk about power system, that communication should be very fast. So that is the benefit of this protocol, which is IEC 61850. So let us talk about it more. The more important things and more pillars which help this protocol to be fast, to be simple, and help IEDs to talk between each other. The first thing is data modeling. The data modeling is how they structure the signal. They make all the data of that any equipment in one short simple signal that can be transferred between any IEDs. So in general, these IEDs, in case anything happen, they will be communicate between each other. So if one IEDs feel there is abnormality in the one feeder, it will ask a breaker to open or trip, then it will be just publishing to others, just to inform them. That is what that standard looking for. So this is the first thing that helps the standard to be very quick and very fast. The other things is how we are configured. Look how we are configured. We have different type of files. The first file we provided from the OEM of these IEDs and like also RTUs, and we will know like a data sheet everything about these IEDs, how it's work, and what is the capability of it. The second one is the SCD. It came from the asset owner or is depend on integrator. It will describe everything, number of feeders, number of equipment, every type of equipment together in the substation and how they should be work. The last thing is we will call it IED. The IED is the last configuration. We will configure it in IED that will be combine all this information together. That in brief, that will tell for IED, each IED when you trip, which IED you should communicate with, and regarding which type of trip you will communicate for different type of IED. So the last interesting topic for this protocol about the communication. In this standard, there is three type of protocol communication. We call it JUICE, MMS, which is and SV. In brief, in this standard, they segregate our substation to three layers. Each layer will have different rules. So the first layer is we call the substation layer, which they are implementing RTU and also any SAS or any workstation or HMI. Then the second layer, we will call it process pay layer, which is for process. It will be between IED, which is will talk to each other. The last layer, it will be at the field, which is between CT and VT with the IED. So in each different layers, when we talk with the others, it will be different protocol. That will help because when we talk about the juice, imagine the juice, we are talking about 3 milliseconds seconds traveling. So what also that between the CT and the IEDs, we try to use a SV protocol, which is more than faster than that juice protocol, which is in microseconds. So each different layers have different rules and different protocols to communicate. And between that, IEDs and the SCADA or different HMI, and this we use MMS protocol. That will help us to build a quick system which is suitable for power and make our power station automation real. So we will convert to the other protocol. The other protocol we are talking between how the RTU in the field will communicate, will talk with the substation, which is with the not substation, with the master SCADA, which is the main control center. The most feature of this, it is very reliable and simple, and it can be used through wide area communication. That in case if anyone have cybersecurity experience, we know if you have that you have field send some signals through public network as you see it in that slide, that we will consider as a threat. So these things we need to consider it in the last slide when we are talking about how to secure, because we use a third party or another company's network area. So let us go to talk about this in brief. This standard, which I call it IEC 104, it is improving a number of protocols. At the early stage, it was one IEC 01, that is only serial communication between the station. And whenever any station that is having a fault model communication, they are connected in the loop. So in case any one of these stations have any communication issue, the rest of the station we cannot see it. It will be out of the communication. So they modify this type from 101 to 104, and this 104 have advantage. It will be convert all the signal through a TCP/IP. But where is 102, 103? 103, to be honest with you, it was used before the GOOS, which is the previous protocol 16850. It was used between the relays and the standard and the RTU, how they are communicate through the serial communication through RGB, RS32, and the rest in serial communication. So that is how we are used this protocol. What they are used, they try to take a sample of the main signals and something we call it AOA, that each signal which are transferred to the main from RTU have a unique number. So whenever that RTU reach that unique number, they will understand they mean that breaker number, certain number, certain value, it is open like that. There is another OA for that same breaker maybe, that means it is closed. So that is the main basic of to understand this protocol. So now we end up with this protocol, and we want to ask how we can secure. Now we reach to another standard, which is called 62351. What we will realize? We realize that both standards and each protocol and beside this standard, whenever they when they are built, they does not consider any cybersecurity. They are only looking for the operation and the performance, like the speed between the speed rate and how it is simple, how it is reliable. But the cybersecurity does not put in their consideration. So uh, to solve this issue, they introduced another standard which we call 62351 to solve the main issue in this protocol. For example, if we take chapter 3 from this, if you can see in the table, for the protocol which is IOC 104, as I said, it will be communicate between RTU and the main control center. So it will be through a public network, and what is provided by server provider. So it is this to solve this issue and to confirm that this protocol is secure. We need to do something called TLS, which is that mean we need to encrypt each signal we send it from the RTU up to main control center. That came through something called encryption, which is a different topic, how we use encryption and this thing in detail. I will not go through it. Another example I will take it, which is as you can see from the table, is when we are talking about the JUICE. We are talking about JUICE and SV protocols. And as I mentioned, they are talking about the speed in millisecond, microsecond. So that will not, we cannot install firewall or something like that. So they try to solve this issue and make it operate as it is designed by do something called authentication and integrity. It is so interesting topic if you go to the deep, and I recommended any cybersecurity engineer to read more about this topic. It is so interesting, and I like to take it, but not here maybe in other session regarding these things. So this is I end up with show you the example how we are can protect or secure these protocols in brief manner, and I hope that all things be enjoyable, understandable for you. And I reached to the end of my slides. Thank you all.
Thank you, Engineer Mohammed. I have one question here, which is related to a question. Sorry, not this one, this one. There's a question from Engineer Hamid Farouk. Does a typical power SCADA system architecture include cybersecurity firewalls? And where are they positioned in the network?
Okay, this is a good question, Mr. Farouk. Look, Mr. Farouk, as I mentioned, if I were returning to that slides, for SCADA, yes, regarding the firewall, yeah, it can be implemented here in control center, where is the main workstations and HMI and other servers. So in that layer, which is in layer 2 and above, we can implement these things between different servers there. But if we are talking about lower than that, it is not to be applicable really, because we are talking about very high communication speed. So I hope that I answered Mr. Farouk.
Okay, thank you. There's no other questions apart from Mr. Farouk questions. So I think that was very excellent presentation. That was very excellent
Thank you.
presentation, Engineer Mohammed, and it was really delighted. We are really delighted to have you and share your knowledge and expertise in this domain of power and SCADA. So thank you again. I would like really to extend ISA Oman team appreciation to your support and your contribution, and looking forward really for future session. So with that, we conclude the session. I will just play the last closeout video for the membership. Please watch it for people, and we encourage all members or all professionals from different backgrounds, engineering, technology, cybersecurity, to join ISA Oman. Just visit the www.isaoman.org, or our LinkedIn page. Just Google it as ISA Oman section. You will find it in Instagram, Twitter, X, LinkedIn, YouTube, and we are happy to answer your questions, anything related to the membership and the benefit for both professional and students. So thank you again, Mohammed, and happy to have you.
Thank
Thank
you
you.
for this opportunity. Really,
Thank
I'm
you.
appreciated. Thank you a lot.
Thank you.
Joining the International Society of Automation. Joining the International Society of Automation as an individual member is one of the smartest career decisions you'll ever make. ISA members have unparalleled access to technical resources and networking opportunities, delivered by a nonprofit professional association that has represented the needs and interests of automation and control professionals since 1945. ISA membership costs just $120 per year and gives you access to dozens of benefits. You can network with other professionals in your local area through ISA's geographically organized sections. You can access cutting-edge technical resources, like ISA's renowned industry standards, online web seminars on hot topics, thousands of peer-reviewed technical papers, and much more. You'll get discounts, 20% in most cases, on your purchases of ISA training, publications, and event registrations, and you'll earn 2 free technical division memberships so that you can join expert communities in the topics and industries that matter to you. Plus, joining ISA opens up a world of leadership possibilities. You could contribute technical content and get published in our magazine or e-newsletter. You could volunteer on a committee or run for an elected position on our leadership team. Or you could contribute your expertise to a standards development committee and change the way we look at technology in the future. There are so many opportunities to get involved, but it all starts with becoming a member of the greatest automation society in the world, ISA. For more details, visit www.isa.org/member benefits.